Hello there, lovely. How are you? Hope you're having a lovely day so far. Tell me how your day has been and what you've been up to, whether you've been going shopping with family or how your brother and sister are as well. We'll do a bit of catching up before we begin the lesson. So, to start off with, of course, as you know, my name is Shabnam and I will be your mathematics tutor for today. So I was wondering what you'd like to go through today, if there's any particular subjects that you wanted to go through, or if we wanted to have a look at any assignments that you have, or go through certain mock exams as well. Did you have anything in mind at all? Yeah, okay. So probability is something that I also find was a very difficult subject when I was back in high school. So we can go through probability and do an introduction to it so that it makes a bit more sense to you as well. Is that what you were looking for? More of an introduction or okay, an introduction. All right, okay, all right. So I prepared some presentation slides for us, and then we can go through that. Alrighty, so let me share my screen. Okay, let's go. Alrighty, are you able to see that? Okay, is that coming through? Yeah, that's coming through beautiful. Okay, alrighty. So again, feel free to stop me at any time should you have any questions or if anything is unclear at all. I know that probability certainly can be confusing, so do let me know at any time if anything is not making sense. So, what is probability? Probability is a numerical measure of the likelihood that an event will occur. So, it's basically like, what is the probability that, it will rain tomorrow? Well, we tend to use probabilities. You might say that it's a 50% chance of rain or a 60% chance of what's the likelihood of this occurring. And we're looking at individual events usually, at least to start off with. Probability values are always assigned on a scale of 0 to 1. So you can go, so that's why we say percentages. So you might say that, there's a 50% chance or a 0.5, chance of it raining tomorrow. So we do use a number between 0 and 1. So apologies, my writing is a little bit iffy, so let me know if anything is unclear. So probability near zero indicates that an event is quite unlikely to occur. If it's zero, it's impossible. So the further you go from 1 back towards 0, the less likely a certain event is to occur. Now, probability near 1 indicates that an event is almost certain to occur. So 1 is certain. So you might say, for example, I would say I am certain that the sun is going to rise tomorrow. Whereas for 0, we would say it seems pretty impossible that an elephant will come barging into my room in the next 5 seconds. should we wait 5 seconds to see? But yeah, so those are some examples of really certain and really impossible things. Okay, let's go on to the next slide. How does that sound? Any questions so far? No, all good, lovely, all righty, okay. So again, we have what we discussed before. So 0 is the event is very unlikely. 0.5 is like it's just as unlikely as is likely. So, one of the examples we tend to use is rolling a coin or tossing a coin because it's a 50% chance you will get the heads, 50% chance you get a tail, or 0.5% chance head, 0.5% chance of tail. So that's an example of something where either is equally as likely as each other. Now, in statistics, the notion of an experiment differs somewhat from that of an experiment in the physical sciences. So we've got statistical experiments are basically where, for example, you might have a dice that is rolled multiple times, and that would be your experiment. And then you would note down the probability, if I was to roll a dice 6 times, what is the likelihood that I would get an even number? So that probability determines the outcomes as well. So statistical experiments are also called random experiments as well. So that's also important to note. So let's have a look at some definitions, some terms, because probability does tend to use a lot of terms. that can be new. So an experiment is any process that generates well-defined outcomes. So I'm rolling a die multiple times. That is my experiment. The sample space for an experiment is a set of all experimental outcomes. So if I rolled my dice 10 times, that is my sample space. So all of those 10 experiments are in that sample space. But an experimental outcome is called a sample point. So each time I've rolled the die, that is my sample point as well. So what number did I get? Did I get a 6? Did I get a 4? Did I get a 3? Those would be your sample points. Now, an event is a collection of sample points as well. And the probability of an event is equal to the sum of the probabilities of the sample points in the event. Now, it can be a bit confusing, and I think you don't really need to know this in a great detail, but I've usually used events as a term more so than sample points. An event is basically like when I rolled the die, the rolling of the die is the event. What is a probability that I'll get a 6? So the probability of that would be 1 out of 6 because, there's only 6 possible numbers in a standard dice. So the probability that I get a 6 is a 1 out of 6. So that is my probability of the event, which is rolling dice. Does that make sense? How do we feel so far? Are we confused? Are we picking up what I'm putting down, or are we a bit iffy? You're okay? All right, let me know if you have any questions. For the time being, we'll continue. So here are some examples of experiments. So tossing a coin, and then these are our possible outcomes. So you can inspect a part, and it could be defective or non-defective. Rolling a die, that example that we gave. And then playing a football game, you can either win, lose, or tie. So these are your experiments. These are your example outcomes. So let's have a look at a sort of a case explanation. So Kentucky Power and Light Company is our example that we'll be using. So they have designed a project to increase the generating capacity of one of their plants. The project is divided into 2 stages, stage 1, stage 2. The possible completion times of these stages are as follows. So we've got our design stage and our construction stage as well. Have you said possible completion time 2, 6? We've got this table as well. Okay. All right. So now we'll use this example as we carry it through. So if an experiment consists of a sequence of k steps in which there are n possible results for the first step, n2 possible results for the second step, and so on, then the number of experimental outcomes is given by n1, n2, nk. So that's each time you're iterating. So it could be 10 steps, and then there could be n to the 1 possible results for the first step, and then you can keep on going and iterating as well. Now, that is a bit confusing, and I think we're not at the stage that we have to understand this fully. But let's have a look at an example here. So in the design stage, we've got, n1 equals 3. So that's how long, this is the completion time for the design stage, and this is the completion time for the construction stage. So in order to calculate the total number of experimental outcomes, we need to multiply them together. Multiplication is important. We're not adding here. And so we get the total number of experimental outcomes, which is equal to 9. We've also got tree diagrams, which are very important in probability. You'll see this far and wide throughout your studies in probability. And we start, for example, the first, it could be, so these are all of branching out all of our probabilities. So we could do our first design step could take 2 months, and then the second will be 6, 7, 8 months. Or if it takes 3 months, so we've got 6, 7, 8 months. So we've got, if it takes 2 months for the design, and then 6 months to construct it, then we've got 8 months total completion time. And then we've also got the longest is 4 months of design and 8 months of construction, so 12 months in total. And you can see these are our sample points over here, and then these are our total values as well. So very important to note this as well if we can. Okay, now we've got combinatorics as well. Now combinatorics is something that I found very confusing in high school. So it's something that we can work at slowly, but this allows us to establish what our possibilities are. Okay, so a second useful counting rule enables us to count the number of experimental outcomes when n objects are selected from a set of n objects. Okay, all right, so we've got some permutations here, and we'll come back to permutations and combinatorics and some of these as we go along. But these again are some examples over here. So example of rolling a die, and then our experiment is rolling the die. This is our sample space. It's all the numbers in the standard dice. And we have a probability of 1 out of 6 of getting each number as well. And then we've also got some more probable examples over here. Okay, so now we'll stop for a second because we've chatted about probability for a while now. And I want to see how you're going and what your thoughts are on this. How have you been finding the probability so far? Does it make sense what we've gone through? Is it a tiny bit confusing, or how are we feeling so far? Yeah, not too bad. That's good. That's good. That's what we know. Probability is confusing. It definitely can be a bit confusing. But what we can do is I'll take you through some more information on probability as well. That I can take you through some questions. Did you want to go through some probability questions? Okay, let's do that. Probability questions. Let's do that so that we can practice and get on top of our probability questions. Okay, alrighty. Now, was there anything in specific that you wanted to go through, like tree diagrams, any Venn diagrams? Not too much? That's okay. Alrighty. So this is a sheet where we can go through different questions and we can work out probability. Okay. Alrighty, so let's have a look at this worked example over here. So when you roll a dice, which number are you most likely to get? Now, this is a bit of a trick question, isn't it? What do you think about this? What would you say is the most likely number? Yeah, well done. 10 out of 10. They're all the same. You're not more likely to get a 1 than you are to get a 5. So they're all equally likely. Now, if you rolled a die 600 times, how many sixes would you expect to get? So now if we roll the die 600 times, well, what is the probability of getting 6? That's right, it's a 1 out of 6. So we just do 1 out of 6 times by 600. Here, let me note this down for us over here. And what was your favorite color again? It was blue, wasn't it? So let's use blue. So it's 1 over 6 times by 600 over here. And you can pop this into your calculator, or we can just do the calculation ourselves. So the 600 goes to the top, just like so. 6 stays at the bottom. And then the 6s themselves cancel out. We're left with 1 at the top. So we've got 100 is our answer. So we expect to get 100 6s if we roll a die. If we roll the die 100 times, 600 times. Okay, all right, let's get rid of that. Okay, so would you expect to get the same number of ones as a 6? Yes, you would, because it's also 1 over 6 probability. Okay, let's have a look. So use one of the following to describe each one of the statements. So I'll give you a minute or two to do this, and then we'll come back and deliberate. So have a think through A to D. What do you think it is? Okay, all right, so it's been 2 minutes or so. So what do you think about the first one? It will snow tomorrow. Yeah, well, I mean, it's probably not too likely with the weather we've got at Melbourne at the moment. So we would say unlikely, but you're right, it's not impossible. It's just unlikely. It will rain tomorrow. Did you say? I also said very likely because it's been raining the past couple of days. So it's probably going to rain tomorrow as well. You win a car in a competition tomorrow. I would also say it's pretty impossible. We haven't really entered any competitions. You were late for school tomorrow. Hopefully unlikely. Okay, Okay, so there we go, just attaching different probabilities to each other. Very, very important. Okay, shall we move on to the next part? Any questions about these two questions? How are we feeling? Beautiful. Okay, yeah, wonderful, wonderful. Okay, so they've got their own answers here. So we're not in Britain, so our answer was a bit different. Okay, so we've got a couple of questions over here, and I'll share this with you in the chat so that you can open this up and look through this, and we'll go through the questions. And would you like to go through them together, or did you want to spend some time going through the question and then we come back and work together? You want to spend some time? Okay, sure thing, lovely. So we're up to question, here we go, question number 1. So let's do that. So we'll take maybe a minute to do this question, then we'll come back and share our answers with each other. How does that sound? Awesome. Okay, and let me know how it goes. Okay, so the student and I will be doing a couple of questions. Beautiful. Okay, so once we've gone through this sheet, I would ask the student how they found the lesson. So how did you find today? Did you have any final questions for me? Any final things we wanted to go through before we conclude our session? Okay, lovely. Beautiful. So just planning ahead for our next session. Any ideas on what you'd like to work on? Yeah, for sure. We can continue probability and go through that. And if you have any questions throughout the week before our next session, feel free to send me a message at any time and we can go through that. I can send you some work examples and take a picture of that as well. So let me know anytime if you require that at all. Now, reflecting on today's session, how do you think it went? Probability is like the combinatorics and permutations. That's probably for the future. I think today was meant to be an introduction, so you don't have to worry about that at the moment. But they are certainly a bit more complicated. But I certainly think you did a great job in the lesson today. Thank you so much for listening so well and for asking all of those really, really good questions. And you did such a great job. You understood probability much better than I did when I was in your position. So you're doing a great job. And together we'll make sure that we're able to fully understand this topic and get you ready for your coming exam. Okay, all right. All right, well, thank you so much for today. It was so lovely to see you. Again, feel free to reach out if you have any questions. I'll also send you a summary of today's lesson and some worksheets that you can go through. And if you have any questions, reach out to me at any time. Okay, have a lovely day. Stay dry. It's been raining a lot lately, and I'll see you soon. Okay, all right, bye. Have a good one.